Today we're going to be looking at Pascal's triangle. Pascal triangle is named after the French mathematician Blaise Pascal. The Pascal triangle is a triangular array of binomial coefficients. How do we create Pascal's triangle? So we first start out with 1, which represents row 0. Then we move down to 1, 1, which will be row 1. Okay, so we initially start with row 0, then we go to row 1, and we get the two 1s by adding the row 0 to 1, which is 1 and 1. Then we move to the next row, which should be 1. Now this is where we're going to add 2, 1. Okay, so we added those two 1s together to give you the middle, which is now row 2. We're going to do the same thing. 1. Add 1 and 2 together to give you 3. Add 2 and 1 together to give you 3. And then 1. So now we're on row 3. Okay, let's move down to row 4. So we have 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And 1. So we're at row 4. We'll do one more row. So we have 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then we have 1. So row 5. So we would continue this same process as far as we need to for our rows. So in a minute we're going to use our Pascal's triangle to expand binomials. I have provided a link for you so if you want to check out other patterns that you see in Pascal's triangle. There's so many different patterns that people see that you may be interested in looking at for yourself. Example 1, x plus 1 to the 4th power. Normally when you see this, you would think that you would want to expand it out, write it out 4 times, and then multiply it out. That can be very tedious, especially if your power is, a large number, 6, 7, 10, so forth. But we're going to use Pascal's triangle to help us. So the 4, the exponent, represents the row number, okay, of Pascal's triangle. So if we go over here, looking at our Pascal's triangle, 1 represents row 0, then 1, 2, 3, 4. So 1, 4, 6, 4, 1. That represents our coefficients that we'll be using to expand our binomial. So the first thing we'll have to do is take our first coefficient, which is 1. We're going to write out 1. In parentheses, I'm going to use my first term in my binomial, which is x, and my power will start at 4. It's going to be multiplied by 1, which is coming from right here, to the 0 power. Okay, so what we're doing is from this term with the x's, we're going to be decreasing our exponents. We start at 4 because that's the 4 that was in our problem. And then we go to the next term, which is 1, and we increase our exponents. So then from there, we're going to add it to our next one. So our next coefficient is 4. So 4 times x, now to the 3rd power, okay, so we're decreasing, times 1 to the 1st power. Okay, so now we're increasing. Remember, from here, we're increasing. Okay, so we're going to add it to now 6. Again, we're getting at the 6 from our coefficients from our Pascal's triangle, times x to the 2nd power, then times 1 to the 2nd power. Add it to our next term, which we're going to use our coefficient 4. So 4 times x to the 1st power, then 1 to the 3rd power. Okay, so just remember that we started out with 4, and with 3, 2, 1. We're decreasing those exponents from x, and then the 1 we're increasing. So 0, 1, 2, 3. We got one more. So we're going to add it to 1 because it's our last term and our coefficients from our Pascal's triangle times x to the 0 and then 1 to the 4th. Okay, so all of our exponents, okay, you see here, 4 and 0 will give me 4. 3 plus 1 will give me 4. 2 plus 2 gives me 4. 3 plus 1 gives me 4. 0 plus 4 gives me 4. So every exponent should have a sum of our original, which is 4. So now we're going to simplify. So this one right here is going to simplify to be x to the 4th, just x to the 4th, because 1 to the 0 gives me 1. And of course, x to the 4th times 1 gives me 1. Plus, okay, this one, we have 4 times x to the 3rd times 1, so that's just 4x to the 3rd. Plus, now this next one. So 1 squared is 1, x squared is x squared times 6, so 6x squared. Plus, now the next one here. All that's going to give you 4x. And then lastly, we're going to have 1. So this binomial to the 4th power was a very easy one compared to what you'll see. But at least it gives you an idea of how we're going to use Pascal's triangle to expand our binomials. Okay, our second example says x minus 2 to the 5th power. So remember, our 5 out here represents our row number. Okay, so that means we have 0, 1, 2, 3, 4, 5. That is our last one we see here. Okay, so this time we're going to use a different way of getting the same answer like we would on the first one. This time we're going to use a chart to help us. Okay, so I'm going to write out all my coefficients. Remember, all these numbers in our Pascal's triangle represent the coefficients that we'll be using to expand our binomial. So we have 1, 5, 10, 10, 5, 1. So I'm going to make a box around all of these. I'm going to now separate them, have separate columns for all of them. So we'll always have, you know, however many numbers in our row for our columns, and then we'll always have 3 rows. So our first row represents our coefficients we have for our Pascal's triangle. So, you know, Pascal's triangle numbers. Okay. Our second row will represent our first term in our problem. So our first term, which is x. And then our last row, so our third row, would represent our second term, which would be -2 for our last row. Okay, so what we're going to do is our first term, which is x. So we always start out with the highest, or you know, our row number, which is 5. Start here, and we're going to decrease going down. So we have x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and of course that would have been x to 0, but you know, that gives you 1. So we'll just, you know, don't really care about that anymore, this section. Okay, so put a little note here that you're going to be decreasing. Okay, you're decreasing exponents. All right, so then the last row, we're going to start with -2, but we're going to be increasing. Remember, we have one of our powers decreasing exponents, and then our other powers will be increasing. So the sum of them should always give us our exponent, which is in this case 5. So again, this one would have been 0, so we don't have to worry about that one. So we're going to have -2 to the first power, -2 to the second power, -2 to the third power, -2 to the fourth, and then -2 to the fifth. Okay, so the last thing when you do, once you have completed your chart, you're going to now multiply vertically. Okay, so let's see. We're going to multiply vertically down, so I'll start the first one. So it's all in order, so that's the good thing about it, is when you're in this way, you're all going to have everything's going to be in order from the highest exponent to the smallest exponent. So 1 times x to the 5th would be x to the 5th. Remember, we had 0 there because that would just give you 1. So that's why we just kind of just, you can leave it blank, put an x through it, whatever you want to do. Okay, so now we'll have multiply this one. So we have 5 times x to the 4th times negative 2. That would be negative 10 x to the 4th plus, in this case, so we'll have 10 times x to the 3rd times 4. So that's 40 x to the 3rd. 10 times, that'll be negative 8 times x squared, so that'll be negative 80 x squared. Okay, so then we have 5 times, that would be 16 times x, that will be positive 80x. And then our last column will just have negative 2 to the 5th power, so negative 32. And so now we're done. Alright, so our last example, we have 3a minus b to the 3rd power. Okay, so the 3 represents our row number. Okay, so we need to go over here to our Pascal triangle. So we have row 0, row 1, 2, 3. So we're looking at 1, 3, 3, 1. 1, 3, 3, 1. Okay, this one we actually have, 2 variables, but again, nothing different. I'm going to use the chart method. I just think it kind of, keeps things organized for you when you're doing this. It's just a preference. So 1, 3, 3, 1. Putting our first row represents all the coefficients for the binomial from Pascal's triangle. So this row will be used for 3a. Okay, now remember 3a, we're going to start out with the highest exponent that we're going to be going to, which is 3. So 3. Then we have 3a squared, 3a to the 1st, and again that would be 0. Okay, and so then we're going to have negative b. Skip this one because that would be 0. We're going to be increasing our exponent, so negative b to the 1st, negative b to the 2nd, and negative b to the 3rd. Okay, so we're going to multiply down. Now remember, don't forget your rules of exponents that will be applied here. Okay, so whenever I multiply this, I need to pay attention to this middle one because that 3 is being applied to everything, so that's really 27a to the 3rd. 27a to the 3rd. Okay, so we're done with that. Now look at this one. The one in the middle, that's going to be 9a squared. So 9 times 3 is 27. But don't forget about your negative b, so it'll be negative 27a squared b. Okay, done with that. Then look at the third one. So that'll be 3 times 3 is 9 times a times, that'll be now b squared, positive b squared. So that would be 9a b squared. And then lastly, that would be negative b to the 3rd. So when you're using Pascal's triangle, just use one of the 2 methods that we've used, meaning, with the chart or without a chart. I think the chart will keep things in order and, make it more organized. But, you choose the method that you prefer.